If we draw 5 cards from a regular 52 card deck, what is the probability that all 5 are going to be hearts? Now your probability is the probability of drawing hearts divided by the total. In this case, now when you draw one card, then you no longer have 52 cards to draw from. When you draw another card, you no longer have 51 cards to draw from. So the total space is going to be how many ways can we draw 5 cards out of 52. So this is going to be a combination where we've got 52 and we're going to choose 5. You see that? The total sample space that we have is that we're going to draw 5 cards out of these 52. What we're interested in determining the probability of is we want to know the probability that all 5 of them will be hearts. Now, out of the 52, 13 of them are hearts. So we want to know the probability that out of these 13 hearts, we managed to draw 5 of those. See how that works? Now, I'm going to simplify this by just pulling up the combination on my calculator. Your different calculators, this is a pretty basic scientific calculator. A lot of the TI-30s, there's a lot of different versions of TI-30s. Some of them actually have a probability key that'll take you to a menu that'll give you a choice of choosing combinations or permutations. This particular one, I don't know if you can see it, but this particular one over the 8 has NCR, and then over the 9 has NPR. That is just another notation for what we're doing here. So some books write this as 13, choose 5. And then this in that notation would be written as 52, choose 5. So it's just a little bit different notation that some books use. They always use one or the other of these. When you do a problem like this, these 2 numbers should be the same. The bottom number here will be the total that you have to choose from. And then the first number here, whether it's here or here, the first number on the top is going to be the total that you can choose from that would satisfy what we're looking for. We're looking for hearts. So there's 13 hearts out of 52 cards. And in both cases, we're looking at how many we're going to get if we choose 5. So 13 choose 5. The way I work this on this calculator is I put in the 13, and then I hit the choose key. Since on this calculator it's over the 8, I have to hit the second function, and then the choose key, and then I put in the second button, the second number, and then I have to hit the equals. And so 13 choose 5, there are 1,287 ways to do that. 52, choose 5, is, hold your breath, 2598960. So 2,598,960 possible ways to do that. And if I divide this out, 1287 divided by 2598960. Wait, are they putting it in as a fraction or a decimal? They're putting it as in a decimal. Okay, so it's 0.00495,198 as far as this calculator goes out. So depending on what the instructions say to do, I don't think they're going to ask you to reduce this fraction, but if they want you to divide it out, they need to tell you how many decimals to go out. So they might go like 495, or they might go 50, since if we go to the decimal place where the 9 is, then we would look one past that. The 5 says round up. You can't round a 9 up, but when you round 49 up, it becomes a 50. So 5 decimal places would be 00050, which even if it says 5 decimal places, you should be able to put 0.0005. So these numbers will be the same. This will be the smallest number, the cards you're choosing, or the meals you're choosing, or flowers you're picking, or whatever. The bottom number here is going to be the total number in the sample that you can choose from. This number will be the total number from the 52 or whatever that will satisfy your interest that they be hearts. So there's 13 hearts in a deck. If it just said red, we'd put 26. If it said face cards, there's 3 face cards, Jack, King, Queen in each of the 4 suits, so that would be 12. If you wanted aces, there's only 4 aces to choose from, so I guess that would be impossible. So let's look at another problem. Might as well get a little more complicated as we go. 4 high school friends belong to the same club in college. And the club actually has 10 members, so the 4 plus 6 more. If 2 people are chosen randomly from the club, what is the probability that both of them will come from the group of 4? This is a very, very similar problem. We have a total of 10 people to choose from. So our total possible sample size, well, let's stick to the notation in this book, is that we are going to choose 2 out of 10 people. Now, we're specifically interested in knowing what the likelihood is that both of those would be from this group of 4 friends. So that is going to be choose from 4, choose 2. So again, notice these numbers will be the same. This will be the total in the sample. This will be the total number from the sample, the subset that will satisfy what we're interested in, which is that it comes from the 4 friends. So once again, I'm going to put this into the calculator. So if I do 4, choose 2, that is 6. There are 6 ways to choose 2 people out of these 4 friends. And then 10, choose 2 is 45. And so in this case, they might leave it as a fraction. Just watch your instructions. 6 won't go into 45, but 3 will go into both of these. 3 into 6 is 2. 3 into 45 is 15. So the probability is 2/15, or if they just want to go ahead and divide that out, that is 0.1333 forever. So there's about a 13% likelihood that the 2 would be from that group before. This is not too low, but these 4 friends make up almost half of the club. So that's not too unusual. That's how you work these problems.